Okay, so please welcome back to the SAT Math. Thank you very much for attending the classes, and really sorry for the delay update of this video. Sorry I was in the business for a long time, so let's come back to our lesson now. Let's check number 21 here. So at number 21 we have that Tom buy a pack of baseball cards every day. Each pack contains 7 cards, but he gave away at least 2 valuable ones to his brother. Okay, which of the following best describe the relationship between times in days and total number of cards in term collections? Okay, so you can see that, for example, he has 7 cards, right? So each day he get he give away 2, so he's left with 5, right? So let's assume the second day is also the same. So 5 plus 5 is 10, and the third day is also the same. So 10 plus 5 is 15. Uh, you can see though for the first 3 days, Tom was giving uh, was getting 5 each day, right? Because he give away at least 2, so maybe he can give up 4 cards, 3 cards, right? Up to up to 7 cards, right? So maybe for the on the third day, he give away how many cards? 3 cards. So he only add 4 cards into his collection. So on the fourth day, the number get to 19, right? And then on the fifth day, he add another 5 in, so it get to 24. And on the sixth day, well, he only adds 3 in, which means he gives away 4 cards. So 24 plus 3 is 27. So you can see, uh, and then maybe next day he give away only 2, so 27 plus 5 is 32. So you can see that the amount of carb is just increasing linearly, right? If you plot this out, this gonna be very approximately similar to a straight line. So we have the relationship here is a increasing linear. Okay, so 21 is A. Number 22 and 23 referring to the following uh, information. Okay, so so James is performing an experiment in which he combines potassium and water to produce potassium hydroxide. Okay, the amount of water W in milliliters needed to create a chemical reaction can be modeled by W equal to 1.6A plus 10. A is the amount of potassium in grams Jane wished to produce. Okay, so water is have a function of potassium. Okay, so W is equal to 1.6A plus 10. So number 22 asks us about what is the meaning of the 1.6. Okay, so you can see here A is the mass of potassium hydroxide or KOH, and W is the mass of water. Now, what they ask, number A, additional 1.6 milliliter of water is needed to react with 1 additional gram of potassium. Okay. Okay, number B, an additional 1.6 milliliter of water is needed to produce 1 more gram of potassium hydroxide. Okay, number C, 1 gram of potassium hydroxide can be produced by reacting 1.6 milliliter of water with potassium, or D, 1 additional milliliter of water is needed to produce 1.6 more gram of potassium hydroxide. Okay, so let's see here. A here is the mass of potassium hydroxide. Okay, so anything talking about potassium only is wrong. So anything talking about potassium only is wrong. But here, number A is talking about only potassium, right? Not potassium hydroxide. So A is wrong. So we cross out A. Okay, let's look at number C. 1 gram of potassium hydroxide can be produced by reacting 1.6 milliliter of water with potassium. Okay, that's kind of interesting. Let's examine number C and number D. A is wrong, so we cross out A because we have nothing to do with potassium. So we cross out A. Okay, let's to black. A. We cross that out. Not correct. We have C and D left, right? We have C and D, and maybe potassium potentially B, and C, and D. Let's check out lesson C. 1 gram of potassium hydroxide can be produced by reacting 1.6 milliliter of water with potassium. Okay, so if we reacting 1.6 milliliter of water, okay. So for number C, if we are reacting 1.6 milliliter of water, 1.6 milliliter of water, okay. So we see milliliter of water here is actually W, okay. Okay, so we start equal to 1.6 times A plus 10. Alright. So okay, let's check it out. I think this one is a little bit problematic. They ask here. 1 gram of potassium hydroxide, okay, which is A. So 1 gram of potassium hydroxide, which is A. So A is 1. Can be produced by reacting 1.6 milliliter of water, okay. So with potassium. This is actually wrong. You know, this equation made no sense, right? You see, this equation is wrong on itself. See, this equation is wrong on itself because you can see we put it A, 1 gram of potassium hydroxide. Okay, so A is 1. By reacting 1.6 milliliter of water. Milliliter of water is W, right? So when you put in the equation, you just see it. This is just wrong. It is just wrong. Okay, so number C is wrong. Number C is wrong because this equation is wrong. Okay, because the equation makes no sense. And D, an additional milliliter of water is needed to produce 1.6 more gram of potassium hydroxide. Okay, so now if you want to produce 1.6 more gram of potassium hydroxide, mass of potassium hydroxide is A, right? So it's equal to 1.6 times A plus how much? 1.6 more gram of potassium hydroxide. So 1.6, and that's puts 10, and that should be 1.6 A plus 10. Alright. Okay, I'm gonna explain number D again. So for D, okay, uh, 1.6 times A plus 1.6, because they say that we want to produce 1.6 more gram of potassium hydroxide, right? And 10, let's calculate the amount of water, okay, plus 10. So that is W, okay, okay, that is actually 1.6A plus 10 and plus 1.6 square. 1.6 square is how much? 1.6 square is 2.56, right? 2.56, I guess. Yeah, it's 2.56. Okay, and that is actually, this is, you can see, this is 1.6A plus 10 is actually W. So that's actually, this is actually equal to W plus 2.6, right? 2.56. Okay, so so they actually need the 2.56 milliliter of water, not 1 milliliter of water, right? So actually the calculation is wrong. So number D is wrong. Number D is wrong. So D is wrong and the calculation is not valid. So D is wrong. So only thing left is actually B. You can see here. Uh, so if we want to produce 1 more grams of potassium hydroxide, we're going to replace A with A plus 1, and now when we expand it, we're gonna get W plus 1.6. So we need actually 1.6 more milliliter of water. Okay, so that's why here, that's why the answer is B. Okay, yeah, kind of complicated, but that's how the exercise go. Alright, so that's the answer. That's why the answer is B, because if you want to increase 1 more gram of potassium hydroxide, you have to add in 1.6 more gram of water. That is B. Alright, number 23. How much more gram of potassium hydroxide, according to your model in gram, is produced for each additional milliliter of water? Okay. For each additional milliliter of water. Okay. So we're gonna still use the equation in the question 22, but here, how much more gram of potassium hydroxide when we add in 1 more grams of no, when you know, like yeah. Okay, I gonna make it, this thing a little bit different, smaller. Okay, I'm gonna just open the new one. Okay, new, save, let's go on. Okay, how much more potassium hydroxide in grams is produced for each additional milliliter of water? Okay, so we have the model, right? So we have the model, number 23, we have the model that what is W equal to 1.6A plus 10, right? Whereas W is water and A is potassium hydroxide. So A is W is mass of water, milliliter of water, sorry, milliliter of water, and A is just grams of potassium hydroxide that is produced. Okay, So how many much more potassium hydroxide in grams, okay, is produced for each additional milliliter of water used? Okay. So so now, uh, for example, W is not now W anymore, but because we add 1 milliliter water, so it's equal to W1 is equal to, okay, 1.6, still 1.6, but time, okay, let's say number A2 and plus 10, so the model is still the same, right? The amount of water, uh, how much more potassium hydroxide in gram is produced for the each additional milliliter of water. Okay, so we add more water in, so W now become W plus 1, and now we have to find out A2, right? In the relationship with A. Okay, so let's find out. So okay, so here we have we just have to solve this equation according to W, right? So here we have W is equal to 1.6 times A plus 10. So if we reduce the two equation, we have 1 is equal to okay, 1.6 times A2 minus A, right? Okay, so okay, so so they ask us for how much more. So they ask us for how much more. So the how much more is actually A2 minus A. Okay, so they ask us to find out A2 minus A. That's just 1 over 1.6. So that is roughly I think that's roughly let's calculate 1 over 1.6. That's gonna return. So that's return 0.625. So that is actually the how much more. Okay, that's actually the how much more. This is the how much more part. So here, this is actually the how much more part. So so that's the answer. So this is actually how much more part, and the answer is actually 0.625, right? There you go. So the answer is actually B, right? Okay. So yeah, 23 is actually B, and 22 is actually B as well. Yeah. Okay, let's come to number 24. A parking meter charged 0.25 for the first 3 minutes and 0.1 for the additional 5 minutes. If Megan is charged $1.35, how much minute did she park for? Okay, so so additionally, so initially she was charged uh, 0.25, right? 0.25 initially. So so the total charge is 1.35, right? The total charge is 1.35. So number 24, the total charge is 1.35, right? So so we know that the initial charge, okay, here, we know that the initial charge is 0.35. It's 25, that's for 30 minutes, and 0.1 for every additional 5 minutes. So this 1.35 is 0.25 plus 0.1 times how many times? So so how many times? It is 11 times, right? 11 times. So which means Megan has parked 1 time 30 minutes. So 1 time 30 minutes. So here this means it's 30 minutes here, right? So and for the, we and she gonna park for uh, 11 of 5 minutes. So 11 times 5 minutes, right? So or 5 minutes times 11, right? Right. So so we just have to add up. We just have to add up this number. So that is gonna be uh, that is gonna be uh, 30 min plus 55 min. So it's 85 min, right? So so the answer is, should be CBD, right? Okay. Let's continue with number 25. Okay. Okay, so they asked us about the equation of a circle. All right. So they asked about a equation of a circle. All right. So for a circle, okay. So for a circle, the equation you have is a characteristic equation for a circle. So for circle, we have the equation like if a point if point xi is lies in circle C with center AB and radius R, then we have equation. Then we have an equation, right? Which is x minus a square plus y minus b square is equal to r square. Okay. Okay. So that is for circle. If xi lies in the circle C, center AB, radius r, then x minus a square plus y minus b square is equal to r square. Okay, so we know that here, we know that the circle has the center of 3 and minus 1, right? And the radius of 4. Okay, so we just have to plug in. We just have to plug in, right? So here 25, right? So we just have to plug in. What do we have here? We have the circle. Okay, I'm gonna just put this aside. I just want to delete this. Please copy for number 24. Alright. Just sorry, I don't have a mouse today. Okay, so now we have the circle center at AB and radius 4. So now we know that from the exercises we know that A is equal to 3, A is equal to 3, B is equal to minus 1, and R is equal to 4, right? So the equation should be uh, x minus 3, x minus a O square. Okay, y minus b, y minus minus 1, which is y plus 1, right? Y plus 1, O square, equal to r square. R square, 4 square is 16, right? So here obviously the answer gonna be B, right? 25 should be B. Okay. Okay. So I think that's enough for the video today. So thank you very much for listening. Any question? Please comment in the comment section down below. Okay. I'm very happy to explain all of it. So so thank you very much for coming today. Yeah. So have a good day. And there you go. You can see it's B. 25 is B, right? So thank you very much for coming today. Have a good day.